have been getting a lot of messages and comments around observability series on my YouTube channel. This is one of the hot takes in the market right now when it comes to DevOps job market, and not just DevOps. If you talk about SRE roles, most of the topics and the heavy focus of the SRE role is around observability. So that is why I have decided to start an end-to-end series on observability, which will cover all the concepts related to it and end-to-end demo using the latest and advanced tools in the market right now. So we'll be doing a lot of things, but before we get our hands dirty, before we start our projects, we need to understand different concepts involved in it. Otherwise it will go above the head, and I don't want to do that. So this is the first video in the series, and in this video we'll be understanding what an observability is, why do we need it, how it is different from monitoring, and what problem does it solve, all the related concepts around it, P99 latency, P50, P95 latency, and all those things. So if you are new here, my name is Piyush. DevOps and cloud is what I do all day long, and I would really appreciate if you subscribe the channel, because your support means a lot and it helps us grow and it helps us produce more quality content like this. So yeah, keep supporting and keep sharing with your colleagues, friends, family, however you want to support. Okay, so let's start with the video then. In this particular sections, we'll start with the difference between monitoring and observability, right? So you might have learned about monitoring earlier, right? Monitoring is when we monitor different metrics. So metrics such as CPU utilization, memory utilization, disk space, input, output, and so on. So when we monitor these metrics, and based on certain threshold, we alert our system if there is something wrong with our machine, something wrong with our server or not. So that's monitoring. But there are certain cases, there are numerous cases actually, in which everything looks green, right? Your CPU is optimal, your memory utilization is optimal. Still, your users are facing the issues. Still, your users are complaining, why is this not working? And why it happens? Because these metrics that you are using, these are not perfect. It was perfect a few years back, but with the complexity that we are living in today, it's not perfect. Dashboard shows everything is green, but your users are still complaining that they are failing to use a particular service, such as users are failing in the checkout card or users are failing in the payment service. Still on your dashboard, everything looks green. So how does a legacy monitoring model works? Let's try to understand the monitoring. Monitoring is the practice of collecting and watching predefined signals. Okay, so these signals are around these metrics, your CPU, memory, disk, your error message, and there are a lot of other signals that are decided in advance, and it tells you exactly what to measure. And once you define that, you define a threshold. Let's say the threshold of the CPU usage is 80% or 85%, or the threshold of the memory is 70%, or the threshold of the HTTP 500 error messages 100 messages per minute, something like that. Right, so you define these thresholds, and then based on these thresholds, you watch the signal. Right, your monitoring tools watch the signals, and as soon as it gets the signal, like the certain threshold has been reached, it will trigger the alert. And it's also known as triggering the page. Why page? Because when, like, if we go few years back when phones were not there, we used to have a device, something called as pager. Like pager is like a beeper in which you get emergency alert. You cannot call from it, but you get an alert for any emergency like situation. So that term page or pager has been widely used in the SRE namespace or in the DevOps terms, and when it comes to alerting based on some monitoring systems. So that term is still being used. We don't have pagers anymore. We have phones, we have other devices, but we still call it a page, right? So page is nothing but an alert that we get on our device, whether it's a phone, whether it's an email or any other notification system, we get the page. I'm just putting more focus on these acronyms that are being used in the industry so that you understand when you read somewhere, or if you have not worked in an organization before, you understand what these acronyms that are being used in the industry so that you can speak the same language when you go to the interview. Okay, so to reiterate, you define the threshold based on certain metrics, and then your monitoring tool watch for the signal. As soon as the threshold is reached, as soon as it crossed the line of the certain threshold, it will trigger the page or trigger the alert. But there is still something wrong. Monitoring tells you when something is wrong, but it cannot tell you why something is wrong. Okay, it provides you only the half information. There is something wrong, it sends you the alert so that you can go and check, you can do the troubleshooting, you can do the debugging, but it does not tell you why is that broken. Let's take a look at this example. So on the left we have a monolithic architecture, on the right we have a modern microservice based architecture. When there was a monolithic architecture, we had few servers to monitor and maybe some database servers, and that's all about it. The architecture were not that complex because everything resides on one server. So you monitor your server at whole, right? You monitor the CPU, memory, disk, network input, output, and everything for that particular server. So there were few metrics to monitor. 10 things can go wrong, and monitoring all of the 10 things is quite reasonable task back then when we were using monolithic architecture. But as the complexity of the application grow, and when we talk about distributed system, there are thousands of things that could go wrong, and each could fail in a different way that has not been failed before, or some pattern that have not been captured before, right? So these all dots, these all circles and different shapes, let's say they each represent one service, and all of these services are connected to each other in a microservice architecture. Now there could be thousands of issues. There could be some connection issues between each of these services or some service. There could be some latency. There could be something wrong with the particular service, or some networking issue between two of these service or multiple service, right? There are thousands of permutation and combination that you can apply. So that's why you cannot write a predefined alert for a failure mode that you haven't invented yet. These are the new issues that you haven't faced before. So how would you know what to monitor? So let's understand a silent failure scenario. Okay, over here is a flow of a request and response end to end. Okay, so a user send the request via the front end, which is green. Then the request goes to API gateway, and then the multiple services such as order service, payment service, and finally to the database. And then from the database, it get the response back, and user get the response at source. Now, what will happen? Everything looks green. All the services are working perfectly. So you are monitoring all the metrics, all the important metrics, all the important signals that you could on these services. But the payment service, which is expected to have 80 microseconds latency, exhibiting 800 microseconds latency. And because of this, the request might timed out, or users might fail some other issues. They get bad experience and their transaction could fail. There could be many things that could go wrong just because of this latency from the payment service. But how do we know that, right? That where is the latency, and how do we know why is the latency is there, right? Because the service is not failing, it's just slow. This is all happening because you have monitored error rate instead of P99 latency. Okay, the signal is there, but the alert is completely blinded by it. Now it is happening because you are only monitoring the error rate. You are not monitoring the latency. And even if you monitor the latency, let's say thousands of your users are there and only a couple of users are facing this issue, then even the average of that latency would not capture anything, right? So you need to capture something called P99 latency. Now, what exactly is the P99 latency? Let's have a look at that. So when you calculate the average in terms of latency or in terms of some other metrics, it does not provide you the complete picture. And then you have to use something called as P50, P95 or P99 latency. P99 provide you the best possible results out of all of these. So P50 latency is something called as median as well. So what that means is it is checking the 50% of the request. That means 50% of the requests are faster than this. That's basically your typical experience. Then you have P95, that means 95% of requests are faster. Only 1 in 20 users experience this latency. So you capture that over here. But when it comes to P99 latency, that means 99% of requests are faster and only 1% of the requests are slower, or only the 1% of all the users are facing this issue. So you are focusing on those 1% users that are facing the issue, right? So that's what we monitor over here. In P99 latency, you are focusing on those 1% users that are facing the latency, and on that you find the average. So you are not finding the average of all 100 users, or let's say if you have 1 million users, if you find the average of latency of that 1 million users, you will not get any noticeable data because only 1% user were facing this issue. But if you find the average of those 1% users that were facing the issue, and that's when you actually find the issue, where is the issue, and then you can debug on that. Okay, so that's why P99 latency is something that provides you the best results out of all of these. But yeah, instead of using average in latency, we use P50, P95 or P99 latency, and sometimes all of these. Okay, so let's understand the monitoring gap and why do we actually need observability. So there are some knowns and unknowns when it comes to monitoring. Okay, knowns are things that we understand and track. Okay, so let's say when your server is slow, you check your CPU, you check your memory. These are knowns. These are something that we understand and then we track. And then we have some knowns and unknown. That means things we know to ask in advance. For example, CPU usage, error rates, right? Something that we can set in advance. So this problem is solved by monitoring. And then there are some unknowns and knowns. That means we have the data for it, but we ignore those things. Okay. And unknowns and unknowns are things that we never anticipated. For example, a missing DB index that could cause cascading latency. That's actually the monitoring gap over here. Something that we have never faced before, we are not actually monitoring it because we have not really benchmarked any metrics for that. And that is an important thing to understand. This is when observability was introduced into the picture. But observability is not something that has been coined with DevOps or SRE, right? It has always been there. In fact, the term was coined first in 1960s by an engineer, Rudolf Kalman, for control theory. Okay, so the definition, the exact definition of this was a system is observable if you can understand its internal state purely from its external component or purely from its external output. So the goal of observability is not to ask, is the system broken? Is the service broken? But troubleshooting and ask why it is broken, how it can be fixed, even if you have not seen this failure before. So that's the advantage of observability over monitoring. So let's take a look at this example. Okay, so over here we don't guess anything. Okay, so this is similar to the example that we have seen earlier, in which the user was facing latency in the payment service, and that is why the response is getting slow to the user. Now over here, if you see, because we are tracing each and every request, we are instrumenting it with rich telemetry, and every request emits a timestamp end-to-end record. That means now we not only know the entire latency of the request, but we know the latency at each and every layer, at each and every service. So we know we get the response back at 820 microseconds, but we also know that payment service took 812 microseconds because the response that it was getting from the payment DB, it was 780 microseconds. So there is the gap. It helps us identify where is the gap. Now we don't have to spend a lot of time in troubleshooting. Now we know where the bottleneck is. Now we know there is something wrong with the database, and then we can directly jump into the database instead of looking into all the service, instead of tracing the request multiple times from different source and destination. We can directly go and check the database, and you can find like whatever the issue is. For example, there could be a missing index on the database. That's why the query was slow. Okay, so now you don't have to add additional metrics, you don't have to redeploy the deployment, you don't have to check anything in logs. You have a visualization with where the execution is slow, and you can directly look into that part. So now if you have a quick look at the difference between monitoring and observability, monitoring defines is the system broken, and observability focused on why is it broken. The target scope is knowns and unknowns. In observability, the target scope is unknowns and unknowns. Unknowns and unknowns as in your like what to trace or what to monitor are also unknown, and the issue that you are facing are also unknown. Right, that could be something that you are facing for the first time, but it helps with that. With monitoring, you know what to monitor. You have those metrics, you set those metrics and signals in advance. That means those are known things only. Now, when it comes to data structure, in monitoring, you use aggregates, average, and counts. Okay, in observability, you use rich, granular, high context event, and we'll look into that. What do I mean by that? In monitoring, you redeploy to add new metrics, right? You add additional metrics based on, like, let's say you have faced some new issues, so you need to now monitor the new metrics as well. But in observability, you query the existing data in real time. You don't have to redeploy anything. Now, there are three core properties of an observable system. If your system has all three, that means it is observable. If it lacks them, you are just guessing, you are just making assumption. So the first is high cardinality data. That means the ability to drill down to one specific request. Like if your system is failing from front end to the database, now you should have the ability to drill down that particular request at each and every phase of the life cycle. Then the second is high dimensionality data. That means the ability to slice and filter data by endless attributes. We'll look into that in the next slide. What do I mean by that? Then we have hypothesis-free exploration. That means the ability to ask arbitrary question in real time without redeploying. So let's have a look at high cardinality or granularity. So when we have low cardinality or granularity, that means we are only tracing, let's say, some errors, HTTP 200 or 4xx or 5xx type of errors. But when you have implemented high cardinality or granularity, you are requesting each of these, which each request and response, each request will have user ID, request ID, trace ID, with the timestamps, with the error message, with the error code, with all the labels, annotations, everything will be there for each and every request. And that's when it makes it observable. And that's when we'll implement observability on it. Then we have dimensionality or the context. So when I said high dimensionality, I mentioned the ability to slice and filter data by endless attributes, right? What are these attributes? Region, service name, database host, user tier, feature flag, tags. There could be many more attributes. So the ability to filter your request based on different attributes is what do we mean by dimensionality. So you should be able to filter the request based on different dimensions, and that's when it becomes important. Now, where do you stand? This is a quick litmus test that you can do with your system. You should ask these questions to yourself. First is, when a user reports a failure, can you find the specific failing request or just the error count? If you are just able to find the error count or the error message, that means you are at this stage, which is the low cardinality or granularity. But when you are able to filter that to the specific request, then that means you are at high cardinality, and this is what the sign of a good observable system. The second is, when an alert fires, do you already have the data to diagnose it, or do you have to SSH into the server and grab log files? If your system failed, right, if you get the error message, and if you just get, let's say, error 404, you are getting 404, but which user it is failing for? What was the request payload for that user? If you don't have it, that means you don't have enough data and you have to log into the server to get the logs and all other things. The third is, have you ever added a new metrics after an incident because you realized you needed it? That means if you have added a new metrics after a new incident, that means you are still monitoring the system. You are not implementing observability. So if you answered no for the first one, okay, and grep log, that means yeah, if you SSH into the server for the second question, and for the third one, If you have added the metrics after the incident, then you are stuck in the monitoring trap and you are not implementing observability yet. So that's a quick test that you can do with your system. So monitoring watches for problem you already know about. When you instrument your machine or you instrument your server, data is collected, but it's hard to connect and search when something breaks. So you have just instrumented it. But observability let you find the root cause of any problem instantly. So you should have monitoring, instrumentation, and observability. So that would make your system more reliable. So to conclude this video, the key takeaways are: first is the limit. Monitoring watch predefined signal, right? It tells you when, but it blind spots hide the why. Okay. You need observability to understand why your system is failing, why your request is slow, why you are not getting the result that you wanted, based on performance, based on system uptime, and various other factors. Then the data. Observability requires rich structured telemetry, high cardinality and dimensionality to diagnose unknown failures. Okay, it needs data. It works on data. Okay, monitoring works only on metrics and its thresholds. And the reality is the difference isn't the tool, it's the data underneath. Better tooling without better telemetry just give you a faster dashboard showing the wrong thing. We don't want that. Okay, that's all about this video. I know it's just a theoretical video in which we did not do any demo because we needed to understand these concepts, and if something is not clear, it will be clear when we do the demo, and it will be clear in the upcoming videos as well. And in the next video, we'll be looking into logs, metrics, and traces and how it helps with observability. Okay, yeah, so that's it from this video. If you liked it, yeah, share it with your friends and someone who could take advantage of this learning. And thank you so much. I will see you soon with the next one. Happy learning.